Hey everybody, it's EJ from EYEDESYN.com, and I'm back with another cool cloth tutorial for you. How to use it in a creative way to create some really cool shrink wrap or saran wrap effects. Take a sphere and suck it to the form of your objects. It's really fun, really easy, really adaptable to whatever kind of look that you're going for. So enough jibber jabbering, let's hop right into it. All right, so here's my collection of objects that I am going to shrink wrap inside, suffocate it inside of a plastic bag. And let's go ahead and let's create our little plastic piece, our little plastic ball. So I'm just gonna get a sphere, okay? And I'm just gonna make this big enough to encompass all of the objects here, okay? And what I can do is even go into the basic tab, turn on X-ray so I can see all of my happy little objects inside. And you also want to make sure, go into your 4-up view, make sure that your sphere is actually encapsulating everything, because if you have any intersection between your sphere, your plastic sphere, and any of your objects, if they're intersecting, you're going to have all types of issues when you start applying the cloth simulation to it. So just make sure that you don't have any intersections or anything like that. And what I'm going to do is just go into my display garage shading lines by hitting N and B. And you can see that we have some uneven polygon flow going on, where we have a very high density of polygons at the top and the bottom of this normal sphere. So what I'm going to do is in the spheres object tab, I'm going to change the type from standard to hexahedron. And what that's going to allow you to do is still have a polygonal flow, but it's a lot more even. And this is important when using cloth. You want to have a fairly even mesh flow, or a polygon size, and good mesh flow. Always big important things there for this cloth simulation. So just keep that in mind. And what I'm going to do is up these segments, because to have more detail, to have more wrinkles in your cloth simulation, or this little plastic saran wrap kind of effect, the more segments you're going to want, the more geometry to get those types of wrinkly details. So I'm going to bring this up to, say, 58, okay? And what I'm going to do is just go back into garage shading here, and now we can start applying some of our cloth simulation here. So we're going to be using the cloth engine for this. It's old, but man, it can still kick some butt. So I'm going to right click on the sphere, go to simulation tags, and add a cloth tag to my sphere. Now I'm going to need these objects to be recognized by the cloth engine and be recognized by the cloth simulation, and have this sphere be able to collide into these other objects. So what I'm going to do is, typically what you would do is, like with dynamics, you would have a dynamics tag and then a dynamic collider tag applied on the objects that you want the collider object to collide into. And typically what you need to do is right click and add a cloth collider on all of the objects that you want to be included in your cloth simulation. But instead of doing that, I just kind of brought all of my objects, placed them into a connect object. So here is your connect object here. I just dragged and dropped these objects into here. One thing you want to do is make sure weld is turned off. But basically, just drag and drop your objects into the connect object, and that's going to connect all of these objects together, treat them as one singular object. And now what that allows me to do is just right click and add a cloth collider to just that one connect object, and not have to deal with applying all these tags to all these objects, okay? So now what I can do is, let's just go to frame 0 and hit play and see what we got. We don't have anything going on. What the heck, cloth? You're leaving me out to dry. Now, the thing you need to understand about cloth is, unlike soft bodies and rigid body dynamics, you need to make your geometry editable, okay? So we can't use live primitive objects to be recognized by cloth. We need to make this editable, so I'm going to hit C to make that editable. And now, if I go back to frame 0 and hit play, now we're going to get some calculation. We're going to get the pinball of death, or the pinwheel of death, and it's kind of doing its thing. For some reason, whenever it starts to initialize for the very first time, it does that. But now you're going to see our sphere just kind of starts falling. And we're having this collision, so that's good, but it's just falling to the ground. Now, we don't want that. We'd want this to get sucked in to our objects and saran wrap everything, plastic wrap everything, shrink wrap. So what we're going to do is go to our cloth tag and navigate to the forces tab here, and we're just going to get rid of gravity, okay? And now what that will do is our object, our sphere will not fall, but it's also not doing anything at all, okay? So we need this sphere to get sucked in to shrink wrap all these objects. So the way we're going to do, or at least the way we're going to start to do that, is go to the tag tab and utilize this size option, okay? This controls the overall size of the cloth. If you consider each of the polygons of your cloth, or of your object in your cloth simulation is held together by springs, okay? And what this size means is that at 100%, we're going to keep 100% of the original size of these polygons and the spring size connecting all of these edges and polygons and all that stuff, or vertices. Okay, now if we shrink this down, what that's going to say, if I bring this down to 60%, what this is going to allow the cloth to do is shrink down the polygons to 60% of its original size. And if I just hit play, let's go back to garage shading lines, and let's actually get out of our X-ray. So I'm just going to click off the X-ray and go. We got our size to 60. Let's hit play. Boop. There we go. And we can see immediately everything gets sucked in. It's so much better with sound effects, okay? So everything gets sucked in, and we got some kind of nice wrinkles going on. You can see that this is almost acting like kind of rubbery kind of cloth where it's kind of inflating, and then we got the blowback kind of happening now too. The one thing immediately we're seeing is that we have a pretty high dense mesh here if I go to garage shading lines, but we're getting all these really janky edges. So what we're going to do is, for the time being, let's just throw this into a subdivision surface. So I have my sphere selected. I'm just going to hold down the Alt or Option key and let go. And you can see that we just made our subdivision surface a parent of that selected object, which is our sphere. And that just kind of smoothed everything out. Now we have a few problems here. Number one, we're getting some intersections with our actual objects, and we're going to worry about that later. We'll fix that a little bit later on. But the one thing is that we're not getting any of these nice wrinkles or anything like that. We're kind of seeing some here, but it's kind of getting sucked in, and it's just not a lot of detail going on right now. So the one thing we can do to fix that, if I go back to frame 0, so why we're not getting any wrinkles is two things. Number one, this flexion, basically what flexion does is allow the cloth springs to kind of fold in or flex in on itself, like kind of flexing your arm, you know, where's the weight room, bro? Is it this way? Flexing your arm kind of wants those springs to kind of, or those polygons or vertices to flex in on themselves. And we really don't want that for this cloth simulation. What we want is expansion of our cloth to be able to create wrinkles, okay? So what I'm going to do is bring down the flexion to 5 and bring this rubber amount to 10. And basically rubber allows for the cloth springs or the clothy vertices to stretch out a little bit more, give it a little bit more give. And I've just found with experimentation that this setting, the rubber setting, is actually, works pretty well for creating wrinkles. And the main problem is that depending on the objects in your scene and the size of your sphere, you don't want the size to shrink down that much, because when you shrink it down to, say, if we have a size of even smaller, like 40, what's going to happen is that the objects, the sphere is going to shrink down so much and so tightly that you're not going to have any give for wrinkles, okay? You're not going to have any room for wrinkles to show up. It's just going to be stretched so much that we're not going to get that, okay? So we're not going to get that wrinkle definition. So what we're going to do is let's try something like a size of 80%, okay? And hit play. Now what this should allow for the simulation to do, in theory, is have enough slack, and you can see it already, to have a bunch of wrinkles here. And we're getting all this intersection, we're getting wrinkles, but this is just not looking too hot. So what we're gonna do is, to prevent the collision, the self-collisions of the cloth, we're gonna go to the Expert tab and go to Self-Collision, check that on, go back to frame 0, and let's hit play again, okay? And what you're going to see is we're going to hopefully prevent all those wrinkles from the cloth from intersecting itself. But we're just getting too much stuff going on here, okay? And what we're going to do is to prevent all of these way too many wrinkles and just way too much movement of those springs, what we're going to do is prevent those springs from moving too far, okay? We're going to have those springs' energy, that oscillation, come to a rest much faster. And how we can do that is if we go into the Forces tab here, we can add a little bit of drag. And I've found that about 20% works pretty well to kind of slow everything down. Now, if I hit play, watch what happens. So we're going to get that shrinking down coming from our size of 80%. And you can see that the movement is way less pronounced. And actually, because of the drag, it really slows down, adds a little bit of like friction. It's making the energy of the springs dissipate so quickly that we're getting a little bit of the wrinkles that I'm wanting, but it's not shrinking down enough to actually get the form of the objects underneath. It doesn't look like a shrink wrap. It just looks like a ball just sitting there not really doing anything. So what we need to do is we can't shrink down this size, because remember, if we shrink down the size, we're not going to get those wrinkles anyways. We need that slack. So what we need is a force to allow the sphere to keep getting sucked in and actually conform and shrink down, or get sucked in to show the 3D form of our objects underneath. And what we're going to use for that is in the simulate menu, we're going to go to particles and we're going to get an attractor. Okay, so what you're going to want to do is have the attractor be in the center of all your objects. So for me, the center of my objects is just 0, 0, 0 anyways in the X, Y, and Z, so that's fine. And what I'm going to do in the attractor is just really up the strength to say 1,000. Okay, it defaults at 10. That's not going to be enough. But if we bring that up to 1,000, let's see what we have now. So remember, we added that drag and it was just too much drag on our object, so it wasn't getting sucked in enough. But now with this attractor, we're getting our sphere, it's getting sucked in, the attractor is kind of taking into effect now. And let's just see, you see that's where we were before the attractor, but now the attractor is actually kind of still pulling in, it's still forcing the sphere to kind of get sucked in a little bit more. And we're starting to get the form of some of our shapes underneath here, okay? So maybe what we have here is a little bit too much slack. So let's maybe change the size to about 75 and see what we have. So a lot of me just kind of discovering this technique was a lot of experimentation, adjusting the size numbers, adjusting the flexion, the rubber, all these different amounts. And again, depending on your scene, it's very important that you understand which of these settings to mess around with. So I think the size decrease is helping a little bit. I think maybe if we increase the attractor to about 1,500 instead of 1,000, because what we need is we just need more force to suck in these the size of the sphere. I guess a sphere doesn't have sides, but the edges, the surface of the sphere to get sucked in to really get the forms of the objects underneath. So we're getting these really nice wrinkles, which is what I'm really digging here. We're getting a little bit of intersection going on. And what I found is that you need to let the cloth simulation kind of go for a bit. And I've found that, you know, for about 50, 60, 70 frames is kind of the sweet spot. So we're still having that attractor do its thing, sucking in all of the polygons of this sphere, and we're getting something pretty nice. And again, this is where you are thinking like, well, this is a lot of wrinkles, but it also looks like it's almost like a shriveled kind of thing, and I don't get the sense of shrink wrap. So again, what we can do is we know that when we have too much of a size, we have too much slack. So let's bring this size down even more. So again, experimentation, knowing which of these settings to really mess around with. And again, this is going to be different for everyone's scene. in the size of your sphere, the size of your objects, but already just adjusting that size to 70%, we're already getting the form of the torus in there, getting some really nice wrinkles, and this is looking really great. I think we hit the sweet spot here of 70%. So again, experimentation. If it doesn't work the first time, you got too many wrinkles, you know to decrease the size here. And usually keeping the stiffness, flexion, and rubber values at 100, 5, and 10, you'll get these really nice wrinkles. The only thing you really have to do is adjust the size. But the only thing that's really wrong here is I'm really liking these wrinkles. We're still seeing our objects peeking through underneath there. Okay, so I hit escape to stop the simulation. And there's a couple ways to prevent the intersection of our objects here. If we go to the Expert tab, we have a couple things to prevent the geometry from kind of peeking out or intersecting the actual geometry, the cloth geometry. And the first is to up the subsampling. So what upping the subsampling does is allows for more calculation power per frame to get more accurate cloth simulations. Now, when you do that, though, it's also going to increase the amount of calculation time and really slow down your playback. One thing I've found that's really helpful is just like you have like the collision buffer for rigid body dynamics, we have a collision buffer for cloth, and it's in the form of point, edge, and poly EPS or epsilon. So epsilon is basically like an imaginary force field or a buffer, and these are the values that you have for the collision buffer between the cloth object and the cloth collider or our object. So what we need to do is just up these values just a bit. So I found that just upping these values of 2 to 2 and 2 centimeters, and we'll just hit play again. And I think about 40 frames is where we started to see the intersection. So we'll let this play out. Still got the really nice folds kind of coming about here. And again, upping these point collisions doesn't add to the calculation speed slowdown. So that's a benefit of just upping the collision buffer. So you see that we're getting these really nice wrinkles. And so far, so good as far as the intersections here. We're not seeing any of those intersections that we once had before. Okay, so I'll let this play a few more frames. So about frame 40 is where we saw those intersections before. But just to prove to you that we're not going to get any intersections. So you know what these do now. So if you have intersections, again, this is going to depend on the size of the scale of your scene, the scale of your objects. I've found that just upping these to about 2 centimeters really helps a lot. And this, boom, just hit escape again, stopped it. This is looking really, really great. So what I'm going to do now is go ahead and just throw on, and I'm in Octane. I have a bunch of Octane materials, and again, I'm going to provide these project files for download if you want. And what I'm going to do is just this is just a simple plastic texture from the Octane library in the live database. And what I'm going to do is I just applied the plastic texture onto the sphere. Let me get this render firing up here, and let's see what we got. Cool, so you see these really nice wrinkles. We're getting a lot of like refraction distortion going on here. So the one thing with cloth or plastic, like if you have a thick plastic or thick rubber or anything like that, it has a thickness to it, right? If it's thick, it has thickness. Really smart comment there, EJ. But anyways, just by default, this sphere is it's basically just one polygon thick. It has no thickness whatsoever, okay? So what we want to do to get like a nice bit of thick plastic has that thickness to it. So to add the thickness to our sphere, what we're going to go do is go to Simulate Cloth and add a cloth surface. And again, I'm going to hold down the Alt or Option key with my sphere selected so that cloth is a parent of the sphere. And the first thing I'm going to do is zero out the subdivisions because I don't need to subdivide this. We already got our subdivisions coming from our subdivision surface. But what I'm going to do is add a thickness here. So watch what happens. We have all this refraction distortion going on. And I'm going to put in a thickness of 1 centimeter. Boom. See what happened is now we added thickness to our, quote unquote plastic cloth. And now we can more clearly see our object And we can go in here and, go into the roughness. And I just added a image texture here, just, some grungy kind of noise. And this, we can add some really nice blurriness in here. And this looks really cool. It kind of makes this frosty kind of look. But you don't want to go too overboard because you do want to see the details of everything underneath. But just a little value of, say, 0.01 or so just adds just enough blurriness to these objects that makes this really look like this is like, I don't know, like maybe even clear latex or something like that has that really good thickness to it and kind of blurs what's underneath. And I think this looks really, really cool. So again, that's with the cloth surface with a thickness of 1. If I turn that off, you can see what we had before. Not looking so hot. I mean, it still looks pretty cool. We get all that weird distortion, kind of abstract stuff going on. That's cool. But we've just added some thickness, and there you go. So looking really cool. So let me just go ahead and turn back on my lights here. So we got some really nice lighting and all that good stuff. And again, I'm going to provide this file for download so you can check out the whole setup and all that good stuff. But one thing is, if you want to create this not using Octane, you can easily do that by just creating a just regular old material, going into the transparency and turning that on, and then adding a little bit of refraction this way, and you'll get that same kind of effect, okay? But Octane just looks so much nicer. At least nicer, faster, so I use that. And because David Ariev, I mean, come on, he's converted me to an Octane person. So yeah, that's basically my workflow for getting this kind of plasticky look. One thing to keep in mind, if you want to just keep this as is, one thing I would do is just command click and drag, duplicate, not that, command click and drag, duplicate this whole setup, hide this, and then just simply delete this cloth tag. And now you can actually just go and have that current state saved. And we still have this backup here ready to go if we decide we want to, play around with the cloth anymore. So that's it. Hope you have fun making nice little shrink wrapped abstract compositions. And I can't wait to see what you guys come up with. All right, so that's a cool creative way you can use the cloth engine to create some really cool shrink wrap or saran wrap effects. You can see it's very easy to set up, just a few settings to understand, to how to manipulate, to get the type of look that you're going for. If you have any questions about anything I covered in this tutorial, please leave them in the comments section below. If you like this tutorial, please hit that like button. If you like what I'm doing here at my channel, subscribe. Hit the little bell thing so you can be the first to get notified for the next tutorial that we come out with. And if you make anything with this saran wrap effect, I love to see what you're making. I get a lot of people reaching out to me on Instagram and tagging me. So tag me on Twitter, Instagram, Facebook. Love to see what you're working on. And as always, thank you guys so very much for watching. I'll see you in the next one. Bye, everybody.